Lesson 3.10, Combining Like Terms. If you had a basket, and in your basket you had 3 apples and 2 oranges, and then you get another basket with 5 apples and 6 oranges, how many would you have altogether? Well, you'd have 3 apples and 5 apples, so you'd have 8 apples, and you'd have 2 oranges and 6 oranges, so you'd have 8 oranges. But you wouldn't say you had 16 orpals. In math, collecting like terms works the same way. We can only add and subtract things that are alike. So in order to identify like terms, we have 4y. Now the term that matches 4y is another term that has a y, 9y. If we have a 3, there's no variable, so what matches is negative 16, which also has no variable. If we have 5x squared, now all of our other terms have x's, but we only have one other x squared, that's 10x squared. And then 2x matches negative 11x. Terms that are not in the same colored box are not alike, and therefore they cannot be combined. For example, I cannot combine 9y and 2x. That would be like putting an apple and an orange together and calling it an orpal. Now, when we collect like terms, we first have to identify the like terms, and then we can combine or collect them. And in order to collect them, we want to talk about the parts of the terms so we know what it is that we're combining. So we have integers, fractions, and decimals. These are numbers standing alone, and they are called constants. If they have no variable on them, they are a constant. The letters are the variables, and they can represent any number, and they can be any letter. Numbers that are attached to the letters, if it's in front of the letter, it's called a coefficient, and these are the numbers that we combine. And if we have an exponent, they're attached to the variables at the back and slightly raised, and the exponents have to match perfectly with the variables. So you look at the variable and the exponent, and they have to match perfectly in order to be like terms. So, for example, I have 3x to the 4th, the coefficient is 3, the exponent is 4, and the variable is x. So now we want to talk about collecting. I have an example, 3x minus 4y plus 5 minus 2x squared minus 10 plus 8y plus 5x squared plus 8z plus 7x. First I want to identify the like terms. 3x and 7x both have an x only, therefore they are alike. Negative 4y and 8y, 5 and negative 10 because they have no variable, 2x squared and 5x squared, and then 8z doesn't match anything, so it's just by itself. The next thing we can do is we can rearrange the terms in the expression so that the like terms are together. And we want to keep the signs with the terms they belong to. So for example, this minus 4y, when we move the 4y, we want to keep the negative with it. So I have negative 2x squared plus 5x squared, 3x plus 7x, negative 4y plus 8y, plus 5 minus 10 plus 8z. Now when we collect our like terms, we add our coefficients together. And we add our constants together. So negative 2x squared and 5x squared, negative 2 plus 5 gives me 3x squared. 3x and 7x, 3 plus 7 gives me 10x. Negative 4y and 8y, negative 4 plus 8 gives me 4y. The 8z is just by itself. And then I have 5 minus 10, or 5 plus negative 10, and that gives me a negative 5. So here are some more examples. I have 5x plus 2 plus 3x. I can rearrange that to put 5x and 3x together, and then I combine them to get 8x. 4x plus 7 plus 4 doesn't need to be rearranged. 7 and 4 are like terms and they are already together. So that gives me 4x plus 11. 3 plus 7x plus 8. The 3 and 8 are like terms, so I put those together. And then I add 3 plus 8 gives me 11, so I get 7x plus 11. 9 plus 6x plus 2x. I don't have to rearrange this. The x's are already together, so 6x and 2x gives me 8x. So I have 9 plus 8x. 3t plus v plus t plus 7v. If there's no number on the variable, it's an invisible 1. So this is the same as 3t plus 1v plus 1t plus 7v. So I put the t's together and the v's together. 3t plus 1t gives me 4t. 1v plus 7v gives me 8 v's. Oh my goodness. That is meant to be a v. I didn't catch that. Sorry about that. Okay, next, 2v plus 8 plus t plus 7. 8 and 7 are like terms. V and t don't have anything alike, so they'll stay the same. And 8 plus 7 is 15. 4y plus 3x plus 2y plus 9x plus 4. 2y and 4y are alike. 3x and 9x are alike, so I'll add those to get 6y plus 12x plus 4. 2x plus 8z plus 3u plus 6z plus 4u. I put the z's and the u's together. 6 and 8 make 14, 3 and 4 make 7, so I get 2x plus 14z plus 7u. And finally, I have x's and y's that can go together. 5x and 2x give me 7x. 3y minus 8y gives me negative 5y, and I still have plus 8.